All right, so in this video, our goal is to use the Pythagorean identity, which is sine squared theta plus cosine squared of theta equals 1. And we're going to use that to find the sine of theta and the cosine of theta. So, real basic example, I've got a right triangle drawn up here in blue. We know from geometry that if it's a right triangle and C is the hypotenuse, we can use the Pythagorean theorem, which says a squared plus b squared equals c squared. And really, that is exactly what this Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1, is talking about. So for instance, if we were to draw a right triangle anywhere on the unit circle, let's draw it on the first quadrant. We know the horizontal side can be labeled as x, or we can call it cosine of theta, since x and cosine we've established are the same thing. And likewise, the vertical side, we can call this side y, or we can call this sine of theta. Both are accurate representations. And of course, the hypotenuse is always 1, because the hypotenuse is the radius of the unit circle. So literally, the Pythagorean theorem says the two short sides squared equal the hypotenuse squared. That's what we're seeing happening here. We're seeing cosine squared plus sine squared of theta would equal 1. So that's where this identity is coming from. So to see it specifically in action, let's do it for the given angle, which is pi over 4, or you could call this 45 degrees. We know in the first quadrant that the x and the y are both going to be radical 2 over 2. So if we were going to officially and formally write this out, so the sine squared of pi over 4 plus the cosine squared of pi over 4 equals 1. Sometimes the notation can be a little confusing about where they put this pi over 4, but basically they're saying, okay, well, what is the y coordinate at pi over 4? The y coordinate at pi over 4 is radical 2 over 2, but then we have to remember to square it afterward. Same thing, the cosine at pi over 4 is radical 2 over 2, but then this square we have to remember to do afterward. The square root of 2 over 2 squared is 2/4 plus 2/4, or in other words, that's 1/2 plus 1/2. And now we can see that this example for pi over 4, Pythagorean identity, does hold true. So let's see another way where we can use this Pythagorean identity. So let's say they give us the sine of theta is -1/2, and theta is in quadrant 3. So theta being quadrant 3 is important because if we're in quadrant number 3, both the x and the y, or the sine and the cosine, have to be negative. So the given sine is already negative. They want us to determine the exact value of cosine. And they want us to use the Pythagorean identity. So the Pythagorean identity is sine squared theta plus cosine squared theta, and you could rewrite this as cosine squared theta first, it doesn't matter. They give us the value for sine of theta. The value for sine of theta is -1/2. And then we have to remember to square it. Cosine squared theta, I know that notation looks confusing, but really all it is a big old variable. In fact, sometimes, as you can see in the next step, I'll shorten cosine squared to just c squared and use just an s when I'm labeling sine. So subtract 1/4 from both sides, and we get 3/4. And then finally take the square root of both sides. We know from an earlier unit this year, when you take the square root of both sides, you get a positive and negative answer. So we get a plus or minus radical 3/2. But since we're talking about quadrant number 3, where x is negative, we only want the negative answer here. So I'm going to erase the positive. And there's my answer. This example also wants us to determine what theta is. For that, I'm going to utilize my unit circle. I know that we're talking about an angle, though, that has an x-coordinate at negative radical 3/2 and a y-coordinate at negative 1/2, and theta is in quadrant 3. So looking at the unit circle, we can see pretty quickly the angle that has that ordered pair is 210 degrees. So the answer to determine what theta is, easiest way to do that is just have a filled out unit circle that you've done and use that as reference. I would encourage you to pause the video and try the your turn number 2. So here's the first few steps. Subtracting 1/4 from both sides. Again, gives me 3/4. Take the square root of both sides, and we get plus or minus radical 3/2, just like we did in the last example. Only difference is, what quadrant are we in? We are in quadrant number 2 this time. In quadrant number 2, the x is negative, which is shown right here. Cosine is x, but the y, or sine, has to be positive. So that means we don't want the negative answer. We only want the positive answer for this problem. So it's positive radical 3/2. See if you can use the unit circle to determine what theta is. So a couple of hints. Theta has to be in quadrant 2 because they told that to us in the original problem. And it has to have an x-coordinate of negative 1/2 and a y-coordinate of positive radical 3/2. If you have a unit circle, this couldn't be really any easier. So I'm looking in quadrant 2, and there it is. 120 degrees has that ordered pair. So theta is equivalent to 120. Now, I should say in this last problem, it's not just theta, but it's sine of theta. All right, finally, they want us to confirm the Pythagorean identity is true for 7π/4. So basically, they want us to show that this plus this is going to be equal to 1. So I'm going to find 7π/4 on my unit circle. It is in quadrant number 4. Here's the ordered pair. The x-coordinate is positive. The y-coordinate is negative in quadrant 4. So it's going to be negative radical 2/2 squared plus positive radical 2/2 squared. And again, basically this problem wants us to confirm an identity. So they just want us to show every single step of this process to show that, okay, we are getting 1 when we square the x and y values. When you square a negative, that yields a positive, so we get positive 2/4 plus positive 2/4. 2/4 plus 2/4, of course, is equal to 1. Pause the video, try the last example on your own. All right, so there's our final answer. And again, all this is the Pythagorean theorem, just using trig notation.